There. Let's see. There. Okay, thanks for the introduction, Magnus. Yeah, so I'm Erik, and I'll be presenting jointly with Andre Kutuso. We're both from the language technology group in Oslo. And so the main focus, like Magnus said, is going to be on NLP resources for Norwegian. I'll do the first half of the presentation where I'll start by giving some background about the research group and kind of the high-level view of just the state of Norwegian NLP, and then I'll quickly go through some of the data sets that we have available currently, both annotated data sets and also raw data in terms of corpora. And then Andre will take over and talk about the more exciting stuff, namely large-scale language modeling and HPC, both in terms of available infrastructure and also collaboration in that space. Okay, so first, just a couple of words about the Language Technology Group, or LTG, like we usually say. So we're at the Department of Informatics at the University of Oslo, where we are now part of a newly formed section for machine learning, where we're joined by research groups working on image processing and bioinformatics and robotics. And we tend to be around a dozen or so people in the group. So currently we count 4 permanent staff, 2 adjunct professors, 3 postdocs, and 4 PhDs. But we also have several openings announced at the moment, actually, both in terms of permanent positions and also PhD fellowships. And in terms of research interests, it's fairly broad. So everything from meaning representations and semantic parsing to sentiment analysis and semantic change modeling and a bunch of other things. Just thought I'd say a couple of things about challenges that are particular to working on NLP for Norwegian as opposed to, say, English. And this would hold for also all the other Scandinavian languages, typically in any small language community, I guess. So the first point is really just this, that we are a small language community, and that means there are fewer people working in the field. That means more stuff needs to be created from scratch by the few people who are working in the field. And we also see sort of less pull from the industry side. So big tech companies like Facebook and Google are sort of eager to get stuff out there for like pre-trained models for English, but we get less of that for small languages like Scandinavian languages. Also, in terms of creating data sets, it's more difficult to use things like crowdsourcing for the simple fact that there are fewer native speakers, and also maybe other more happy facts that we have higher average general income and fewer people actually willing to take on the job of doing things like crowdsourced annotations, which tends to be not so well paid, which is a less happy fact. The way researchers and research groups are evaluated is another factor here. So it has sort of evaluated through sort of counting of publications and counting of citations, and this sort of incentivizes people to work on English, since it's easier to get published, easier to get recognition for the work you've done and get cited. But things are starting to change, I think, both in the field as a whole. There's now more recognition for sort of data set papers, and also more recognition for the importance of targeting other languages beyond English. And turning towards working more on Norwegian has been sort of a priority at LTG for the last few years. Another peculiarity of Norwegian is the fact that we have 2 official written standards. So, I mean, in terms of spoken Norwegian, there's a zillion of crazy different dialects. And fortunately, we're not working on speech recognition. We're focusing on text. But even for written Norwegian, there are 2 official standards: bokmål, which is the majority variant, and then nynorsk, which is a smaller variant used by 10 to 15% of the population. But there's a requirement that all sort of public information from government agencies needs to be 20 to 25% nynorsk. So it's certainly something we can expect to encounter when working with Norwegian text. Another sort of peculiar thing, in contrast to English at least, is compounds, like you have in Swedish as well. So where something like bus driver strike would be 3 words, when in English it's a single token, busschaufförstreik, in Norwegian, which simply means you have, of course, more unique tokens, but also it's more of a need for sort of character level processing. GPU access is another issue. So I guess we're fairly fortunate in Norway, since we have, at least compared to, say, Sweden, I think we're still better off in terms of GPU access, in terms of having fairly solid national e-infrastructure. But everything's relative. So if you compare ourselves to, say, the Finns, they have certainly access to more GPUs in their national infrastructure than what we do. Andre will have a few more things to say about this particular point later. Okay, so one term we often hear talk about in NLP is this notion of low resource languages, right? And that can be defined in several different ways. So here's one definition from a paper by Chieri et al. From 2016. Which focuses exactly on criteria for sort of selecting low resource languages for low resource language programs. And they define low resource languages as those that have fewer technologies and especially data sets relative to some measure of their international importance. So then, of course, another question is how to define international importance. But if we, for the sake of the argument, take the number of black metal albums as a measure of international importance, then it's fair to say that Norwegian, at least going a few years back, must certainly be taken to be a low resource language. But of course, if the story stopped there, then this would be a very short talk. And fortunately, things are progressing. And since at least 2014, Norwegian has started to sort of gradually shift from being a low resource language to being more of a high resource language, or at least a higher resource language. And as I said, working on Norwegian has been sort of a priority for LTG over the last few years. Okay, so what happened in 2014? So now I'll turn to quickly try to go through what we have in terms of annotated data sets at this point. And the thing that we got in 2014 was the Norwegian Dependency Tree Bank. And this was a collaboration between Språkbanken at the National Library and also the University of Oslo, including LTG. And the Norwegian Dependency Tree Bank annotates about 600,000 tokens, half of that for bokmål and the other half for nynorsk, and enables the training of sort of the full standard pre-processing pipeline. So for tokenizers, lemmatizers, pro-speech taggers, and dependency parsers. This data set has also been converted to universal dependencies. And the tree bank is, of course, sort of the basis for the support for Norwegian that we now have in sort of off-the-shelf tools like UDPipe, Spacey, and Stanza. And here are just some performance measures from Stanza for both of the two language varieties. And basically across all tasks, performance is actually fairly decent. So this is something that is certainly very useful. So here's another example of support for Norwegian in sort of off-the-shelf tools. So this is an example of named entity recognition for Norwegian using Spacey. The example here is a quote from Camilla Stoltenberg, which is sort of the Norwegian equivalent of Tegnell, although a slightly less controversial figure maybe, where Camilla Stoltenberg is recognized as being a person, and FOE, which is the Norwegian National Public Health Institute, is recognized as an organization, and so on. This particular quote, an example, is from early last fall, actually, where I prepared this particular slide, but unfortunately, this quote didn't quite hold true. And we've seen a new sort of wave of COVID since then, as most other places. Okay, but the Spacey named entity recognition model is trained on a data set called Nordne, which is basically named entity annotations that we've added to this Norwegian dependency tree bank. So this was released last year and was, again, a collaboration between the National Library and LTG, and also the Schibsted Media Group. And you see the distribution of entity types here in the table, basically just to show that there's a fairly rich set of entity types. So we've, for example, adopted the notion of geopolitical entities as an entity type, like in the ACE guidelines. I won't be going into much in terms of sort of evaluation measures, but I just thought I would mention this evaluation of BioLSTM that we've run on the named entity annotations, just to show you some of the interplay between nynorsk and bokmål. So here we see models trained on both the bokmål and nynorsk sections separately, and also a model trained on the concatenation of the bokmål and nynorsk data. And so the results in italics here that corresponds to sort of cross-standard testing. So for example, training a model in nynorsk and then testing it on bokmål, and we see that the performance drops quite a bit actually. But what we also see is that if we train a model jointly on the concatenation of these two data sets, we actually see better results, or at least comparable results, as to when training sort of single standard models. And we've seen similar results for dependency parsing and part-of-speech tagging. And this is nice because it means we can get away with having just a single pipeline or a single model for processing nynorsk and bokmål, rather than having to do language identification and then choosing what pipeline to apply. Okay, so sentiment analysis has been a focus of ours for the last few years at LTG. So we have an ongoing project called SANT for sentiment analysis for Norwegian text, which has basically been sort of a series of different annotation efforts based on this first underlying corpus that we created called the Norwegian review corpus, which is basically a collection of reviews from across a bunch of different categories provided by the media partners in this project, Schibsted, Aller, and NRK, the public broadcaster. And a peculiar thing with sort of Norwegian consumer journalism and arts journalism is that everything gets rated. Norwegians are very happy about, or fond of rating things, it seems. And we always use the die as a symbol for representing the ratings. So everything gets assigned a rating using the same uniform scale from 1 to 6, which is nice for us because it's easy to then collect data across multiple domains and get sort of good coverage. So everything from home electronics, books, literature, movies, the normal stuff, to political speeches and athletic performances and wine and insurance policies and what have you. Everything gets rated with a throw of a die. So the underlying idea when we created Norec was that we could take these die ratings as sort of weak labels to train models to perform document level sentiment analysis. And of course, in general, reviews are well suited for doing sentiment analysis since they're sort of by their very nature packed with sort of subjective evaluations. In this particular example, you see the annual review of Norwegian Christmas soda or Christmas pop. And here's an overview of just the categories that are covered at this point. So currently the Norwegian review corpus has a bit more than 40,000 reviews distributed across these categories. So screens, so that's things like movies, TV series, that sort of stuff, music, literature, products, games, restaurants, and so on. And they tend to be fairly long, so they average at about 500 tokens or so. So they're fairly long, these reviews. They're also professional reviews. Unfortunately, in terms of using this for document level sentiment analysis, the distribution of ratings is fairly skewed. So we see that ratings of 4 and 5 comprise the majority of the ratings. It sort of spikes at 5. So a majority class baseline here, if we were to treat this as simply a multi-class classification problem, would be 36% accuracy. And the models that we've trained so far, I think the best performance we have seen for a hierarchical attention network, which manages to get an accuracy of just above 60% for doing this. Of course, accuracy isn't the best metric for evaluating this, since, yeah, these classes are actually have a distance between them, but it gives you an idea of the performance here. But of course, document level classification is very crude, and in practical applications, it's often desirable to be able to do something more fine-grained. So for slightly under 10% of the reviews in this data set, we have added fine-grained sentiment annotations. So for about 400 documents and 11,500 sentences, we've added annotations of polar expressions, holders, target expressions, and positive, negative intensity graded on a 3-point scale. So like in the example you see here, svært stillegående, the property of running in a quiet manner, has been annotated as a polar expression, pointing to the disk as its target expression with a strong positive polarity. So this subset, or this layer of annotations, is referred to as Norec fine, and then we recently added another layer of annotations to this, which we refer to as Norec neg. So this will be documented in the forthcoming Nodalida paper. So where we have added annotations of negation cues and negation scopes. So for the same set of 11,500 sentences. And then the next step here will be to try to take this into account in modeling, right? Since negation obviously is important for sentiment analysis, but we've added this annotation to all the sentences in this subset, not just the ones that are sentiment bearing. Okay, so basically, based on this Norec corpus, we now have sort of this family of data sets that we've created. I mentioned most of these already. Norec sentence is basically just an aggregation of the fine-grained annotations to the sentence level. And then Norec gender is the subset of book reviews. There's about 4,000 of them, where we've added annotations of the gender of both the critics and the book authors. So this allowed us to look at things like, are there differences in terms of how male or female critics review the works of male or female authors? And also try to experiment with things like gender classification. Okay, so that's basically it of the most central sort of annotated data sets. There's also a few other resources I thought I could mention. So we have a corpus of parliamentary speeches. So there we've used the metadata indication of party affiliation as sort of a label for trying to basically classify party affiliations based on the speeches. And then there's a few of lexical resources as well. So like lists of synonyms, we have an adaptation of the Google analogy data for Norwegian, and also a Norwegian sentiment lexicon, which is also adapted from English, sorry. Well, generally we try to aim to sort of develop things from scratch rather than trying to adapt things from English. So this is the last data slide that I was planning on including. So this is basically what we have currently in terms of large or large-ish corpora that can be used for training things like embeddings and language models. And of course, we have things like Wikipedia, which is always available. There's about 200 million words in total for the Norwegian Wikipedia. We also have a resource called Novak, which is a Norwegian web corpus of about 700 million words. And then the corpus we tend to use the most, which is something called the Norwegian News Corpus, which has about 1.7 billion words of newspaper texts. There's the common crawl, of course, where it's always possible to extract data. If I don't have a current estimate of the count there, but I mean, also depends on how you perform language identification, for example. The National Library of Norway also maintains a couple of corpora. So one is the collection of public domain texts in a resource called NB Digital. So this is mostly historical sources. So this is OCR'd typically, so there's some noise here. It's also possible to filter this data based on the sort of certainty levels of the OCR. And then finally, there's something called a colossal Norwegian corpus, which is again maintained by the National Library, which basically consists of everything I mentioned above here, in addition to all the non-public domain texts that they maintain. But again, this is mostly historical sources, a lot of text dating back to 1814, and again, mostly OCR data. So there's certainly going to be some noise there, but at the same time, there's a lot of it. So reportedly, there's about 18.5 billion words currently. Okay, so that's it in terms of what we have. Then I just have one slide on what's still missing before I'm going to leave the word to Andre. So one thing that's still missing is annotated data for anaphora resolution or co-reference resolution. That's something we're currently working on, again, together with the National Library. So we're in the process of annotating the Norwegian dependency tree bank for co-reference. And then also label data for things like inference, hate speech, entity linking, several other tasks that we would still like to get in place. And also in terms of non-annotated data, we're also hoping to be able to collect larger corpora of not only news texts that we mostly have so far, but also user-generated content. So things from social media and from the comment sections of newspapers, stuff like that, which would be super useful to have, since often practical applications actually targets that kind of data more than newspaper data. And finally, we're also hoping to get in place sort of a larger ecosystem of pre-trained large-scale contextual language models for Norwegian. Things like BERT, Roberta, Electra, GPT models, and so on. But here we are now at least well on our way. And I think that's a good place for Andre to pick up.
Yep. Okay. Hello, everyone. Let me just share my screen. Yep. You see my slides, right?
Yep.
Okay. Thanks. Yeah. So, what do we have to actually solve the data sets that Eric was describing? What language models for Norwegian do we have in our hands? Just this January, the Language Technology Group at the University of Oslo has announced the release of the first BERT model fully trained from scratch on Norwegian data, the so-called NURBERT, and you can see this nice puffin, who is our mascot, the mascot of this NURBERT model. So this was a large event for us, quite important. And in my part of the talk, I will describe NURBERT, but not just NURBERT, but other models as well. So yeah, it's not just BERT. We actually have launched the so-called NURLM initiative, which is like the project to create a large collection of contextualized pre-trained language models for Norwegian, not only for Norwegian maybe. This is a joint project under the umbrella of the so-called Nordic Language Processing Laboratory, NLPL, which includes, among other initiatives, the EOSC Nordic, European Open Science Cloud, the Sound project, which Eric has already mentioned, and it's coordinated by our language technology group in the University of Oslo. And as I've said, the aim of this NURLM initiative is to provide models, supporting tools for NLP practitioners who are interested in Norwegian, both from industry and from academia. We will be presenting a paper which describes this initiative and the models at Nodalida this year. It's also to appear at archive in the nearest days, maybe tomorrow. But you but you can already check it up, check up all the necessary information at this website, norlm.nlpl.eu, where we describe our pre-trained language models. And yeah, it's important that, well, at least it's important for us that all these models were trained using Norwegian National Supercomputing Services, precisely the Saga HPC cluster. So yeah, we have this large so-called NLPL vector repository, which is which contains hundreds of distributional semantic models for multiple languages, and of course, including models for Norwegian, and currently we have around 70 different Norwegian models, both trained on NuNorsk and Bookmol, and joint models as well. Of course, most of them are static embeddings, like Word2Vec, fast text, GloF, etc. Trained with different hyperparameters, like lemmatized corpora, non-lemmatized corpora, different vector dimensionality, etc., which allows the researchers to study the effects of these hyperparameters on the distributional models. But recently, in the recent 2 years, we also started to include contextualized embeddings, like LSTM-based Elmo models and transformer-based BERT models, including NURBERT, which I have already mentioned. Yeah, but in fact, this repository also includes models for dozens of other languages. So the idea is to provide the researchers and industry and industry practitioners with the possibility to download models with clearly stated hyperparameters. Each model is described in detail, like what corpora it was trained on, what hyperparameters were used, etc., etc. All right, but it's even more than that. So we provide not only just pre-trained models, but also the so-called virtual laboratory. So it's like everything necessary for fully reproducible training of these models. It is built using the EasyBuild framework, which provides like fully automated installation procedure, which allows you to, for example, to create like fully identical training environments on different computing infrastructures. Like, for example, we currently deployed this virtual laboratory on Saga HPC cluster in Norway and the Puhti HPC cluster in Finland, which allows us to conduct fully reproducible experiments and do other nice stuff right now. But actually, even more machines are coming. Like in the end of this year, the Lumi supercomputer will appear on the European scale, and we hope to deploy our NLP virtual laboratory on Lumi as well. So it's due to to progress from almost raw Linux operating system to fully optimized, custom-built TensorFlow and PyTorch, fully prepared to train, for example, a BERT model in just a couple of commands. So we have a Git repository where you can which you can clone and use it to deploy your own training infrastructure, which will fully 100% reproduce what we had. And this virtual laboratory is actually part of the NLPL collaboration on cross-border academic HPC access in Nordic countries, in which, for example, Norwegian researchers get access to Puhti supercomputer cluster in Finland, and Finnish researchers get access to Saga in Norway, and this includes Denmark and Sweden as well. Okay, so now let's talk more about like technical details about the Norwegian models that we trained as part of this NeuralM initiative. I will first talk about LSTM-based Elmo models. So Elmo was actually the first, I guess, well-known contextualized embedding architecture using 2 layers of bidirectional LSTMs. The paper about Elmo by Peters et al. Got the best paper award at the NACL 2018. And actually, although transformers are of course more fashionable now, but in many cases, at least in our experience, Elmo delivers comparable performance with much more relaxed memory and training time requirements. So we feel it is important to provide these models as well and not to focus exclusively on transformers only. So we have several Elmo models for Norwegian. The numbers here are the identifiers of the models in the NLP vector repository. So this first set of models for Norwegian is the models number 210 and 211. They're both trained on the Norwegian bookmall Wikipedia, and they're different in that one of them is trained on lemmas and another on just raw tokens. And depending on the task, like one or another of them might be better. And actually, these models were the first full-fledged Elmo models for Norwegian. There used to be the project called Elmo for Many Lengths, which provided Elmo models for multiple languages, but they were trained on very small corpora samples, and actually they were useful only for things like syntactic parsing or something like that, but not for semantic tasks. So yeah, as I've said, these models are trained on Wikipedia only. But this was not enough, so we felt that Norwegian Wikipedia is not that large, unfortunately. That's why we launched the second set of Elmo models for Norwegian, the so-called NeurElmo 30 and NeurElmo 100, which are trained on the same training corpus that Norbert used. And I will talk more about this corpus later, but it contains both Norwegian Wikipedia, both Bookmall and New Norsk parts, and the Norwegian news corpus, Norsk corpus, which Eric also has already mentioned. And this training corpus contains 2 billion words, which is much more than just Norwegian Wikipedia. So these models usually yield better performance than the previous set of models for Norwegian. So we recommend to use them. And these 2 models are different in only one aspect. So one of them is trained with 30,000 words in the target vocabulary, and another with 100,000 words. Of course, since Elmo uses convolutional layer to actually process the input words, it means that it doesn't have any problems with the auto vocabulary words anyway. So the size of vocabulary doesn't mean that you will have more or less auto vocabulary words. It just means that the model was trained on the language modeling with the language modeling loss, which uses which use the vocabulary of this or that size. So it kind of means that the first model is better with the top frequent words, and the second model is better with less frequent words. Right. So we released these models both as TensorFlow checkpoints and as HDF5 files, so they're fully self-contained and ready to be used. We also provide a Python package, which is called Simple Elmo, which is intended to to make the usage of Elmo models as simple as possible, as you can see from the name. It works with TensorFlow under the hood, can work with both TensorFlow 1 and TensorFlow 2. And essentially, we did not create it from scratch. This is a modernized code from the original Elmo authors, but made more convenient for everyday usage, and updated to work with TensorFlow 2. And it's really as simple as just load the model, feed your sentences as lists of words and just get contextualized Elmer representations for these sentences. So yeah, this is really simple and fast. Yeah, we also just to kind of to encourage experimentation and exploration with contextualized models for Norwegian, we created a demo web service as a part of the so-called web vectors service, where we kind of visualize Elmer representations as the so-called two-dimensional text. So a user can input a sentence in Norwegian and get the nearest, the most probable lexical substitutes for each word in this sentence. And of course, since the representations are contextualized, these substitutes are dependent on the full context. And so you can kind of play with this service and get nice rephrasings of your input sentences. Sometimes quite funny, but also can be used, for example, in for teaching, like for explaining students how contextualized distributional models actually work and how their representations depend on the context. Yep. Okay. And now to more trendy stuff. NURBERT. As you all, of course, know, BERT model is stands for bidirectional encoder representations from transformers, and the paper about BERT got best paper award at the NACL 1 year after the Elmo paper did the same. And this is actually the bread and butter of modern natural language processing. But until recently, until this year, in fact, the only BERT for Norwegian which you could use was the Google's multilingual BERT, or so-called MBERT, which was trained on dozens of different languages. And in principle, it could be used for to process Norwegian NLP tasks. But of course, this is probably not the best solution. So, as I've mentioned in the beginning of my talk, we trained BERT for Norwegian from scratch, entirely on Norwegian data, with the custom Norwegian vocabulary, which contains about 30,000 word pieces, including all the diacritics which are used in Norwegian, which actually improves tokenization a lot in comparison with Google's multilingual BERT. So, for example, for this sentence, which you see on the slides, the multilingual BERT will split it to like a hell of a sequence of word pieces, which do not make much sense linguistically. While NURBERT would split it into quite meaningful words and morphemes, which more or less make sense from the point of view of the morphology of Norwegian. So you can see that, for example, Kvinne fotballen is much more sensibly tokenized than with Google's multilingual. So you can see that NURBERT knows much more about how Norwegian words are built. And we feel it's quite important for studies which are interested in like what knowledge about language, what knowledge about linguistic structure language models actually have. And yeah, this model, the NURBERT model, can be used and downloaded both from the well-known Hugging Face model hub as LTG Oslo/NURBERT, and it also can be downloaded from our NLPL vector repository as the model number 216. It was trained on a joint training corpus, which contains both bookmall and NUNORSC data. Of course, bookmall is dominant, but still it is a joint corpus. And as I have already said, there are 2 billion words, 200 million sentences. It contains mostly news texts and encyclopedic texts. They were sentence segmented using the recently published tool, which is called Stanza. We needed sentence segmentation to make sure that the next sentence prediction task in BERT works as intended. The architecture of this model is 100% identical to Google's BERT base case. So it's 12 layers, hidden size of 768. It was trained on Norwegian HPC cluster Saga for about 3 weeks with on 16 P100 GPUs. It could be less if we had more modern GPUs, of course, but 3 weeks is actually quite a moderate time, I think. We used a very nice BERT implementation by NVIDIA, which allows to do multi-node and multi-GPU training, which you won't get with the original BERT implementation from Google. At our wiki, we have the description of the full process, so you can easily reproduce it if you want. We also have a special Git repository with everything that we changed in the NVIDIA code and all the utils which we used for NURBERT, all patches that we employed, experimentation descriptions, evaluation workflow, etc., etc., etc. Yeah, I will not talk much about the details on training workflow. If there will be any questions about that, we can get back to this slide. But essentially, this is the same as the original BERT. So it was trained in 2 phases. One phase with maximum sequence length of 128, and another with the maximum sequence length of 512. This is just the plots of how the loss was going down. And yeah, the most interesting thing, evaluation. It turned out that we are not alone, and almost concurrently with us, another BERT for Norwegian was released, the so-called NB BERT by the National Library of Norway project called NOTRAM, Norwegian Transformers, Norwegian Transformer models. They are also going to present their paper at Nodalida this year, so we are in contact with them, and I think our papers are quite complementary to each other, so they it will be a nice kind of a sequence of papers. And the NB BERT by the National Library is trained on this colossal Norwegian corpus, which Eric has already mentioned. It is 10 times more data than NURBERT, but as it was already said, this corpus is mostly books which were OCR'd, which means noise, and also many of these books are quite old. And also another issue, it can be an issue or it can be a benefit, of course, it depends on your task. So the NB BERT is not trained from scratch. It was initialized with the multilingual BERT weights, which means on the one hand that it was a meaningful language model from the very start. But this also means that the vocabulary of this NB BERT contains 120,000 subword pieces, most of which do not have anything to do with Norwegian at all. So of course it contains word pieces from Chinese, Russian, Japanese, Portuguese, etc., etc., etc. It can be argued that this can be useful sometimes, but still, of course, most of them probably are not needed to process Norwegian NLP tasks. And this also means that fine-tuning this NB BERT model is a bit slower than fine-tuning NURBERT with its 30,000 word pieces vocabulary. So the larger vocabulary means larger model and slower fine-tuning. But anyway, so what are the scores? These are the evaluation metrics for some of the NLP tasks that we are describing in our paper. So for part of speech tagging, both NURBERT and NB-BERT from the National Library of Norway are much better than the multilingual BERT by Google. NB-BERT is a bit better than NURBERT, but a bit slower as well. It's quite interesting that Elmo model is, as I've said, not much worse than the BERT models, but its training and fine-tuning takes radically less time. So it's like 2 orders of magnitude faster in this task. On sentence level binary sentiment classification, the raw amount of data which was used to train NB-BERT starts to show its benefits. So we can see that the BERT model from the National Library of Norway is much better than all the rest of the models. But NURBERT and NURELMA are still much better than the multilingual BERT by Google. And finally, on fine-grained sentiment analysis, where we have to actually find what is the target of the sentiment, what is the holder of the sentiment, etc. Both NURBERT and NB-BERT are on the same page. So it's kind of the conclusion is that actually all the models that I've mentioned can be the best depending on the particular NLP task that you're interested in. So if one is doing some NLP for Norwegian, it definitely makes sense like to try both NURELMO and BERT, both NURBERT and NB-BERT. Some of them can be faster or slower, some of them can be better or worse. Yeah, but anyway, it means that we have a choice, which is always good. Yeah, and to repeat a bit what Eric has said about what's next, we definitely need a comprehensive benchmark sets for Norwegian. So it certainly would be nice to evaluate all these models on more trained tasks like natural language inference, question answering, etc. But unfortunately, we don't have such data sets for Norwegian, so it definitely would be good to develop such sets like something like super glue or something like that. We also plan to train separate bookmodel and Norsk models, BERT and Elmo, to find out what the differences are and how they can be used in cross-lingual transfer. Then, yeah, as Eric has said, we're going to try to collaborate with the National Library so as to train on larger but cleaner corpora, maybe. There is an ongoing initiative on training something like joint Nordic models, maybe like on Norwegian, Danish, and Swedish together, and see what comes out of that. So there are already several projects which start to think about that. And yeah, we have recently got an invitation to conduct a pilot testing of the Lumi supercomputer in the end of this year, and we plan to train like more resource-heavy models for Norwegian and other Nordic languages on this supercomputer, including Roberta, Electra, GPT-T5, etc., etc., etc. Yep. Okay, so I guess that's it. Thanks from me and Eric and from our Norbert Puffin. And if you have any questions, we both, I guess, will be happy to answer them.
Perfect. Thanks for a really good presentation. I'm really happy to see there's lots of interesting stuff going on. There's no questions in the chat, so just leave the floor open. Do we have any questions from the audience? I'm going to pause the recording now, so don't be afraid to